first slide.
Which was what happens if you, for example, shine light onto something dark? Or what happens to the energy that interacts with the matter? And when the electrons, I told you, when the electrons then fall down on the next lower energy level again, after they've been sort of excited, we would see that as fluorescent. But sometimes we don't see it. It is just simply, this energy then is simply turned into heat. And that is when you shine light onto a black surface, that is why it gets warm, the black surface. Now here's an interesting question for you. What color is the skin of a polar bear? It's black. Absolutely right. The skin of a polar bear is black. Woo! Why is that? What is the advantage?
Because black absorbs all the colors in the spectrum of wavelength.
Yeah, but why is a polar bear white? Why is a polar bear white? How does that work?
It's camouflage.
It's camouflage, yeah. Actually, the hairs of a polar bear are designed incredibly smart in terms of engineering. They are like fiber optics. And in this fiber optic, you said that? In this fiber optic, you can transport light, so the outside light is collected by each single hair of a polar bear, and it is transferred onto the black skin. And this black skin then absorbs the energy and heats up the bear. And to avoid any kind of reflection out there of the warmth of the heat, you have a cover of very thick protective insulation that reflects everything back, which is the white coat. So bears are incredibly clever. Did you know that every single polar bear is left-handed? Has nothing to do with the light. I just thought you might want to know that. Okay. So on that note, you will be now very successful in the next game of Trivial Pursuit. Okay, let's go to these questions here, or the comprehension questions, very quickly. Hopefully we will get that done within 20 minutes. So the first question is, what is the molar concentration of 10 milligram per milliliter solution of the BSA? The molecular mass is 66,000 gram per mole. Well, actually, forget that here, because if it says the relative molecular mass, it usually doesn't have any unit. If it says the molecular mass, then it would have gram per mole, but both are absolutely the same. So what are we looking for? We are looking for the concentration, the molar concentration, so this would be mole per liter. Do we have mole anywhere? Yes, we do. I just scratched it out. So we have mole per 66,000 gram. Now the mole are in the right place. Let's try to get rid of the grams. Do we have grams anywhere? Yep. We have grams. So we have 10 times 10 to the minus 3. That's the milligram divided by 1 times 10 to the minus 3 liter. What happens to the grams? They cancel out. What have we got left? We've got mole and we've got liter here. This is exactly what we want. Hee-hee. So all we have left, and we can even cancel the 10 to the minus 3. So all we have left is 10 divided by 66,000. And the unit would be mole per liter. And the rest is something for biochemical pedestrians. So you just put that into your calculator and you get 1.5 times 10 to the minus 4 mole per liter. Did you get that? Yeah? Does it deserve an Alexander? Simples? It is simples, isn't it? How many moles of BSA are there in 3 milliliter of a 1 milligram per milliliter solution? Again, what are we looking for? We look for moles. We had the moles in the relative molecular mass, so that is mole divided by 66,000 gram. So the mole is in the right place, that's good. We need to get rid of the grams. Times 1 times 10 to the minus 3 gram. That's from here, divided by 1 times 10 to the minus 3 liters. So the grams cancel out. We've got the liters left. We want to get rid of the liters. Times 3 times 10 to the minus 3 liters. That's this guy here. Liters cancel out. We've got mole left. That's what we want. You can, if you come across something like that in an exam or in a test, please feel free to say, hee. Yeah, at least then I know, I get some feedback that, it was all right. So we have, basically, we can cancel that out, and we have 3 times 10 to the minus 3 divided by 66,000 mole. And that gives 4.55 times 10 to the minus 8 mole. Do you agree? Yeah? Alexander, yes or yes? What is the percentage concentration weight per volume of the 10 milligram per milliliter BSA solution? So we have 10 milligrams per milliliter. And what we can do with that is we can actually cancel out the little m's. Because the m's stand for 10 to the minus 3. We can simply cancel that. So a 10 milligram per milliliter solution is the same as a 10 gram per liter solution. True? Well, if boss says so. It's the same as 1 gram per 100 milliliter. Yeah? Just divide numerator and denominator by 10, and I get 10 gram divided by 10 is 1 gram. 1 liter divided by 10 is 100 milliliter. So it is 1 in 100. It's the same as 1% weight per volume. That's a 1% solution. That's almost an insult to your intelligence, isn't it? Or do you like to be insulted in a test? Determine the volume of 200 micromolar BSA required to make 5 milliliter of a 25 micromolar solution. C1 V1 equals C2 V2. This is our working solution. This is our stock. This is what we have. This is what we want. So we just simply rearrange that. V1 equals C2 V2 divided by C1 equals 5 milliliter times 25 micromolar, bless you, divided by 200 micromolar. If it was micromolar and millimolar, I would have to change it into a common unit. But since it's both micromolar, I just leave it and cancel it out. So I have 5 milliliter times 25 divided by 200. And that is 0.625 milliliter. Is that correct? Yeah? So I want 5 milliliter of that solution, so it's 0.625 milliliter of the stock, and the rest 4.375 milliliter of water or buffer. To make up the 5 milliliters. Okay? Happy? Is it worse than Alexander? Probably not. Now, this one is definitely worse than Alexander. Because this was the only question where you had to think a little bit. So how are we going to tackle that? So what is the concentration of the solution made up by mixing 3 milliliter of a 10 micromolar and 1 milliliter of a 30 micromolar solution? Now we are looking for a concentration here. Yeah? And we know that concentration is mole per volume. That's what we are looking for. Now let's try to figure out how many moles we have in total. So what we have is basically 3 milliliter of a 10 micromolar solution and 1 milliliter of a 30 micromolar solution. So in the first place, what we can do is we can ask how many moles do we have here and how many moles do we have here, right? And again, that is pretty straightforward. For the first part, we say mole. We have 10 micromolar, that means 10 times 10 to the, what is micro? Minus 6, 10 to the minus 6 mole per liter. Mole is good. Now we need to get rid of the liter. So times 3 times 10 to the minus 3 liter. That's this part here. Liter cancels out. And we have basically 3 times 10, that's 30. I can do that in my head. 10 to the minus 6 times 10 to the minus 3 gives? Loud? 10 times to the minus 6 times 10 to the minus 3. Exactly, you just add them up. 30 times 10 to the minus 9 mole. So that's for the first one. For the second one, we do exactly the same. Mole. We have 30 times 10 to the minus 6 mole per liter. This time we have only 1 milliliter, so that's 1 times 10 to the minus 3 liters. Cancels out. So we have 30 times 10 to the minus 9 mole. So what do we do with that? We pour them together. So we add them together. What do we get from that? What is our total volume? What's the total volume? 4 milliliters. So we have 30 times 10 to the minus 9 plus 30 times 10 to the minus 9 gives 60 times 10 to the minus 9 mole in a total volume of 4 milliliters. I write that. So we have 60 times 10 to the minus 9 mole in a total volume of 4 times 10 to the minus 3 liters. And that is fairly easy to calculate. It is 60 divided by 4 is 15. 10 to the minus 9 divided by 10 to the minus 3 is 10 to the minus 6 mole per liter. Or if you like, minus 6 is micro, thank you. 15 micromolar. So the trick here was to think, right, I have to do it via the mole. Did anyone get this answer? Hands up? Yeah. Quite a lot of people did. Excellent, well done. Yeah. This means that you really understand the concept and you can play with that. Do you have any questions? Are you happy with that? You should be able to basically now tackle whatever issue concentrations throw at you. It's not getting any more difficult. Happy with that? Ladies and gentlemen, go in peace. Have a lovely weekend.